this video, we will spend 5 topics to talking about the programming challenges within this chapter 3, describing data with statistics. The challenge topic are linked with the program we have done or learned in the previous chapter. So in this mind map, you may see the linkage I gave to you. For example, today's program, we will do some enhancement to this correlation coefficient, the figure calculation, so that we will base on this existing the code we did in the chapter 3.5. And moving to next topic is to do this statistic calculator is may use the way we learned how to deal with the txt file, as well as the number 3 is how to deal with the CSV file. So gradually you may see more and more linkage. I will put into the mind map. That is purpose give you certain connections for the knowledge and the skills we have discussed, and hope you can also connect those knowledge in your mind. So let's go to today's the challenge. The better correlation coefficient find program. We already have this find core xy, so we did that in number 351. So we have this one. Let's save that, copy this to another one and rename. So we have this 38 better find. Okay, so that is our base, and let's to do this. Better correlation coefficient finding. So, and today is 18. So, what's the needed is we did that between two sets of numbers, but we have the big assumption. So let's see. So we didn't implement that, but I have mentioned this during our learning. So our assumption is the two sides has the same the numbers or the same length from the list point of view. Let's improve the function so that it first check the length of the list. If they are equal in the length only, then should the function proceed with the remaining calculation. Otherwise, it should print an error message that the correlation can't be found. So correlation can't be found. Actually, that's also based on this assumption. But we can see if we have our different correlations, the length from the list, or different length of the list from the two data sets is maybe proceed and they just ignore the rest of the things. So that part is we learned from this zip. So, but let's ensure is we are using this check. That can be make sure is we verify the data size before we do the action. So let's do this find this one. So before we do this n equal to that, let's implement this check. So I got x and y as our input. So it's very easy. So the checking part is length x, whether it's equal or not. So if it's not equal, what we will do? So we will return. So return none. So we will print the two data sets has different numbers of elements. Then we will return, but we need to return something which we will use these keywords return none. So if we go get, let's see, so here, so if I get is 1 is give us 6. So I want to print this. So first, okay, so let me do save. Correlation unsupported format string passed to none. Return none. So if length, then I think it's that's the difference. Return none and print all. So this one, let's make that comment first. So let's just verify. It doesn't. Let's do the call. So we haven't called that. Just make sure is we want to go. Oh, the two data set has different numbers, and if they have the same number, then we will do this correlation, the find. Because it's a different number, actually I cannot print those because there is one here I gave our 2f. So that is the, let's not have this one because it's none doesn't have our floating. And I put this on comments to see the data type. Okay, so two data types has different number. So coefficient is now the result is none. So that is expected for our program. Actually, these are already the enhanced. But let's the author also in his solution gave some more the enhancement. One is try to the update this kind of the this find the sum. So we have did on this find the sum of the product is use the product as empty and utilize this zip. But actually is this one is a product can be done is directly. So let's see. So this is the method 1 using zip. So let's comment them and method 2. So this 2 is I read from the author's the solution. It just use one line, the simpler line. So it's xi. So we have for the xi times yi directly for xi yi in zip x and y. So this is already the kind of the simplification than this one. So you can see here. So it's generate the same result. And now let's do the testing for same length. So you can get is minus 1.0. So still this result. So and then the if not so how to handle this none? So none is just the not. So print is could not because it's none. So let's see. So if so we put that correlation result is as the when is really the equal. So if not call. Return correlation. we gave our variable number, so find is this one, find correlation. So if that is our arrow, then this we will print that is correlation coefficient is not could not be calculated. Yeah, let's just make this, and then the else. Else is print this one. So now let's see. So it's just the query. Let's run this. It's come to this -1. Let's do the testing. Put this to another length. So first, within our find the correlation function, we got this error message from the inside, and then this come to here. Return none is actually the false for this result. So this result now is flow into this not correlation, then we will print this line. So this one is we practice also this none. So from here, let me make our comments. None can be checked as false in Boolean. Yeah, so with this, I think it's, you can utilize this to prevent you read our two length, different lengths list. And it's actually, if you don't have that, this will still be calculated. So, but that will be not correct. So thank you for your watching for this first challenge. Next challenge, we go to the statistics calculator to see how we can do that in the code. Bye for now.